Hello, AP Calculus students. It's Mr. Ford here with another homework tutorial. Today we're looking at 721, and if you're watching this after class, we just kind of started to learn the basics of U substitution, and we're going to get a chance to practice a little bit of that today as we look at some of the problems on this homework. But first if you notice that the last several days have been pretty much starting the same way in this homework section. You've been doing a bunch of derivatives followed by a bunch of integrals, which is pretty much good because we're keeping ourselves fresh for that AP Calc test, which is happening in less than a month from now, which is cool. 755, we're so close to the end. Man, we're so close. 755, we're going to differentiate. So let's start there. I noticed that A is, there are ways to get around this, but the best way to handle A is to do an implicit derivative. I know it looks like you could be able to maybe take the square root on both sides, and yeah, that would be a good idea to try, but I think it'd be better and more accurate, and you get the same answer anyway if we just did an implicit derivative, which is what we're going to do. So I'm going to rewrite question A off to the side here. We have y squared equals 3 cosine of x, and let's go ahead and jump into it. Let's start by taking the derivative. Remember, we're finding the derivative with respect to x here, so 2y takes care of the power rule, but dy dx has to be the kind of the unknown derivative of y with respect to x that we are looking for in this problem. And as far as 3 cosine of x, that's going to be negative 3 sine of x. That's all we really need to worry about there. Derivative of cosine is negative sine. At this stage, we can now just divide over and call it good. I kind of like this answer a little better than what the book has printed. Dy dx is equal to negative 3 sine of x over 2y. And I kind of like that. Now, you could make the argument that y is equal to the square root of 3 cosine of x, in which case your answer would change a little bit. It would be negative 3 sine of x on top still, but the bottom would be now plus and minus. Sorry, I should have put a plus and minus in front of it. Plus and minus 2 times the square root of 3 cosine x. It's kind of up to you how you want to write this answer. It depends on what you're looking for. If you want it as a implicit derivative with x and y, or if you want it to be all in terms of x. Those two answers are actually equivalent because you've plugged in the value of y there. Question B is really similar. And we're just going to do a bunch of quick derivatives here. So question B is tangent squared of the square root of x. That's a pretty straightforward chain rule problem. Well, I say pretty straightforward, but it's a triple chain rule, so let's try to keep our heads on straight. Let's start with the outermost layer of this thing, which is going to be the exponent to the second power. So for that's the last thing to happen. If I'm going to plug a number in for x, I'm going to take the square root, then I'm going to take the tangent of that, and finally I'm going to take I'm going to square that. So let's start with the power rule. 2 times the tangent of the square root of x. Now that's all well and good, but now we need to do the derivative of the next thing, which was the tangent. Tangent's the middle layer. The derivative of tangent is the secant squared of the square root of x. Because again, we're taking the derivative of the inside layer. In this case, we've already dealt with the squared, the power rule, so now we're dealing with the tangent. The derivative of tangent is secant squared, and now we got to deal with the square root of x. That's the inside part there. And the derivative of the square root of x is, let me use red, 1 over 2 roots of x. And now you're done. Now you finally got your derivative all the way shaken out. There's a lot of simplification you can do with this. I mean, the only thing I noticed right away is that the 2's will actually cancel out of this. So your final answer will be tangent of the square root of x times the secant squared of the square root of x over the square root of x. There we go. Question C is another derivative or trigonometry based sine of cosine of x. Another chain rule problem. This will be a little simpler though. So the derivative of the sine, let's deal with the outside part first. The derivative of the sine is the cosine of the cosine of x. And that's that. Next, we're going to multiply by the derivative of the cosine, which in this case is the negative sine of x. And, honestly, that's my answer. I'll clean it up a little bit. I'm going to move the negative sign to the front. Negative sine of x times the cosine of x. You'd think there'd be some sort of function out there for the cosine of the cosine, but there isn't. And there you go. A couple derivatives to start us off today. Next, we got a bunch of integrals to think about too. So let's deal with those. I'm gonna write them just like before. I'm gonna rewrite them down over here. The first one is the integral of 3x minus 5 squared. Dx. Again, we're thinking about chain rule today. U substitution is a way to kind of get around the chain rule. If you really want to get heavily into U substitution, what you might do is write something down like, okay, let's call U 3x minus 5. And now I know that du is just 3 dx. And so if I wanted to, let's see, I'm trying to remember how this works now. So what I would do is I know that 1/3 du is equal to dx. And so what I can do is I can replace the 3x minus 5 with the letter u, and I can replace dx with 1/3 du. So I can rewrite this. Let's call it the integral now of 1/3 u squared du. It's now the exact same integral. The 1/3, of course, you can ignore, and now what you have is 1/3 times u to the third over 3 plus c, like that. And now you can back substitute in your u. This would be 3x minus 5 to the third power over 9 plus c. Now that is the u substitution version of how to handle this integral. You could alternatively expand out 3x minus 5 squared and do it that way, and that would give you the exact same answer. I'm not really in the habit of doing that for this problem, but this is the more formal u substitution version. The other way to do it is just to treat it like a standard antiderivative thing and then lay your trap. You need that 1/3 as the trap for the 3 to fall in when you do the derivative. So there's that too. There's a lot of different ways to handle this answer. If you expand this all the way out, I'm just going to note, I'm looking at the book's answer over here. If you expand it all the way out, you do get 3x to the third minus 15x squared plus 25x plus c. That also works. That is what happens when you expand this out and then divide everything by 9. You will get that polynomial. So there's another way to think about it. Question B is another one. We got the integral from -3 to 3 of 9 sine of pi x. This one we actually have to evaluate. Did I get that right? Sine of 9 pi x? Or is it 9 sine of pi x? Okay. Dx. Again, the first challenge here is to actually take the derivative. Or if we're clever about this. Ooh, you know what? Watch this. I'm thinking about this really quick. This is from a trig perspective. You know what? Let's try it really first, and then I'll show you what's going to happen here. So the first thing we need to do is kick that 9 out in front, because it's just a constant, so it doesn't really apply to anything inside of the integral. The next, we can think about the antiderivative of the sine of pi x. Ignoring the u substitution that we're doing right now, I want to just take the antiderivative of this. The derivative of cosine is negative sine, so I need a negative cosine of pi x is this one. Now the problem is if I take the derivative of the negative cosine of pi x, what I'm going to get is I'm going to get sine of pi x, but I'm going to have to multiply by pi from the chain rule. So what I want to do is lay a trap for that pi to fall into, so I'm going to put this over pi. And I think that will work. And this is the one that we're going to evaluate from 3 to -3. Like that. Here's the thing, is that if you plug in, and now before we go to evaluate this, I just want to explain something. If you plug a 3 in for x and then a -3 in for x, we're going to get let me just write it out and then I'll explain. You'll have negative cosine of 3 pi over pi minus negative cosine of -3 pi over pi. And at this point, you should grab a calculator because there's no way to evaluate those numbers. Or maybe not 3 pi. 3 pi is just going to be 180 back to 0, back to 180 again. So that's -1. So this is 9 times, let's see, negative cosine of -1. This is positive 1 over pi minus negative 1 over pi minus 1 over pi. It ends up being 0 because this whole thing ends up 0. like that. Now, here's the thing. I could have told you that answer at the very beginning of the problem, because sine is what is known as an even function. Here, I'll show you. Let's look at the graph really quick. Let's just graph 9 sine of pi x. And let's specifically graph it on the window from -3 to 3. Let me just show you what's going on this graph real quick. And I only need my y to go from like -2 to 2. Oh no, -10, because there's a 9 in front. You'll see the graph looks kind of like this. What happens is that the area under the curve on the right side balances out what's on the left side. You have this hump and this hump are positive, and this hump and that hump are negative, and they cancel out, and then this also cancel out. So because sine is an even function, and you're doing integral from the same number to the positive version of that same number, this is going to be 0. I could have told you that at the top of the problem. So, sine, whenever you have negative a to a of a sine function, it's going to be 0. So that's a lot of work for that problem, but anyway. Question C. This is a really easy one. We can do this one right here. I don't need to rewrite it again. Because they told us that m is a constant, because look at that, we're taking the derivative with respect to x. It's dx. So all we're really going to do here is put down a parentheses, put down 6m to the -7 plus 2, because that's just a constant. We're going to throw an x after it, and then put a plus c on this thing. That's all you got to do. Let's go to the next problem. 757, Sam the Snowman has a spherical head and is melting at a rate of 12 inches cubed per hour. Assume that as it melts, his head remains as spherical. What is the radius of his head when the radius is changing at 0.25 inches per hour? This is a related rates problem, and they gave us pretty much everything we need, so let's just think about it really quick. 757. We are thinking about a sphere that is melting over time. So let's draw a picture of a sphere really quick. And the only thing that a sphere has as far as variables go is the radius. They told us that dv dt is decreasing. It's melting. -12 cubic inches. -12 cubic inches per hour. -12 inches cubed per hour. And we want, this is interesting, we actually want the radius when dr dt is 0.25. We should mention, by the way, that 0.25, that will be negative since there are no positive numbers in the case of the melting snowman's head. -0.25. I think it's interesting that they left out the negative. They kind of wanted us to get it for ourselves. So, at this stage, the problem becomes a game of finding an equation. I knew that would happen. Shoot. It becomes a game of finding an equation that relates these things together, which is actually pretty easy to do because it's a sphere. So the volume of a sphere is 4/3 pi r cubed. Actually, I'm going to write that down here. Move it down. But of course, this doesn't help us. We need to know the rate equation. We got to know what's going on as things are changing, how the change in volume and the change in radius are affecting each other. So dv dt is going to equal 4 pi r squared times dr dt. And this is interesting because we're solving it for r. But we do know dv dt, we do know dr dt, so let's go ahead and plug those in from that number, those numbers in, and let's get to work. dv dt is -12. We got 4 pi times the radius squared times -0.25. Let's go ahead and divide out all of our constants. Let's divide out 4 times 0.25, or 4 times -0.25, which is the number -1, actually. So we're basically dividing both sides by -1. That's interesting. Oh yeah, the more I think about it, these are going to cancel out. 4 and 0.25 cancel out. Let's divide by pi also while we're here. So we can cancel out our pi. So we're going to get a positive 12 over pi equals r squared. So all we need to do here is take the square root of 12 over pi. And I like that answer because it's exact, but if we go to the calculator, we can get a decimal answer, which probably makes more sense. The radius would be about 1.954 inches at that moment in time. Yeah, that's good. Cool. I love a good related rates problem, especially one that's really straightforward and easy to solve. Let's try 758. This is going to be more of an analytical problem. What's the value of a such that the parabola a squared plus 3 is tangent to the line of y equals, I should look up what that and that number actually is because I can't see it on my black line master here. It is 5 minus x. Y equals 5 minus x is what that equation is. So let's set up some space to work on this problem over here. This is 758. We are looking for a value of a such that the parabola y equals ax squared plus 3 is tangent to the line y equals 5 minus x. So we're kind of thinking about this backwards. If I'm thinking about this the correct way, we've got some parabola, ax squared plus 3, and we need its tangent line to be 5 minus x. So we're looking for the value of a to make that happen. I'm going to rewrite this as negative x plus 5. So the first thing that I notice is the tangent line has a slope of negative 1. So what we need to do is we need to find the derivative. We need to figure out the derivative here, dy dx. We need it to equal negative 1. That's the first challenge. So let's do that. The derivative here would be 3ax plus 3 equals negative 1. Now the tricky part about this is that the tricky part here is that we are dealing with two variables. We have an a and an x going on. Negative x plus 5. Negative x plus 5. We need this to be negative 1. So, well, if we keep going, let's just isolate the ax in this equation. It would be negative 4/3, if I'm thinking about that right. Do I know any other information about this problem? Let's see, the other thing that we need, maybe we treat this like a system of equations. Maybe think about that, because in order to be tangent, they actually have to be the same thing. So maybe what we can do, they have to equal each other also at this point. The x, y points have to be the same. So another thing we can do, that's our derivative part of it. We also know that ax squared plus 3 has to equal negative x plus 5. They have to be the same thing at that point too. So this is going to turn into a quadratic equation real fast. It's going to be ax squared plus x minus 2 equals 0. Or ax squared plus x equals 2. Those are the two ways to think about it. What I'm thinking of doing right now is actually solving this equation over here for a and then substituting it in over here. Thinking about this like a system of equations. So a is equal to negative 4 over 3x. And I kind of want to plug that in for a over there, which will be nice because it's going to knock the x squared down a degree, and then I can actually get an answer. That'll be cool. Let's try it. So we'll have negative 4 over 3x times x squared plus x equals 2. And now the x's kind of balance out, so it's negative 4x over 3 plus x equals 2. And it might be best if I just multiply everything in this problem by 3 right away and get negative 4x plus 3x equals 6. I'm just going to multiply everything by 3. Man, I hope I'm right. I am not correct. Yikes. This problem might need a little more time for me to think about how to approach it. X squared plus 3 equals 5 minus x. There's 2. I know the derivative has to equal 1. So, or am I a moron? Am I an absolute moron? I'm an absolute moron, guys. Don't listen to anything I have to say ever. Don't do it. Don't do it. Don't do it. That's a 2. So this is a 2. So that means that this is shoot as priest. This is negative 2 over x. Oh my god. You guys must watch. Do you watch these videos at home and just go like, you're an absolute moron, Ford? You're an absolute bonkers moron. Negative 2 over x there. So that changes a bunch of things over here. That means it's just negative 2x plus x equals 2. And that means that, oh, but that's not right either. So, well, so negative 2x plus x of negative x equals 2. Now I'm thinking, did I make any other dumb mistakes? Oh my god. And of course the 3 goes away. Holy crap. Holy crap. Okay, I'm starting from scratch here. That part's correct. These parts are correct. I don't know how to do a derivative, apparently. The derivative of ax squared plus 3 is 2ax equals negative 1. Because the derivative of ax squared plus 3 is just 2ax. And that's it. So I know that a is equal to negative 1 over 2x. That's where I'm going to start right there. Then I'm going to come up here, and I'm going to put this as x squared over 2x, negative x squared over 2x, plus 3 equals negative x plus 5. Okay. The 1 of the x's cancels out here. So I have negative x over 2 plus 3 equals negative x plus 5. So if I add x to both sides, this is interesting, I get x over 2, positive x over 2, plus 3 equals 5. And that means that x over 2 equals 2, and that means that x is 4, which, according to the textbook, is the correct answer. Oh, that's nice. So, since x is 4, that tells us pretty much everything, because now we can plug that in right there, and I know that a has to be negative 1 over 8 by plugging in 4 for x, and I know that the y-coordinate, the matching y-coordinate over here, is going to be 1, negative 4 plus 5, which is 1. So that tells us everything. It means that the slope is, that's what we're looking for. So a, that was the answer. A is negative 1 over 8. That was the constant we're looking for. And the point they intersect is the point 4, 1. There you go. Woof. Okay. Whew. Got out of that one alive. Only had to do a derivative correctly. You can see where my one easy mistake unlocks the entire problem. So that was, I guess, fun to see. I don't know. Okay, let's look at 50, 60. We're going to skip 59. 60 is pretty straightforward. The velocity of a plane flying from San Francisco is given by v of t. Keep in mind that is the velocity of the plane. And t is measured in hours, v of t is miles per hour, and we're looking for the average velocity. Since the unit that we're looking for the average of is the same as the function that we have, we're going to use the integral version of the average. So the formula here for 760, I'm going to work down here, 760. We are just going to do 1 over. We're looking for the first and fourth hours. So 4 minus 1 times the integral from 1 to 4 of the velocity function, v of t dt. Let's go ahead and clean that up and plug in the function, and we'll go to the calculator for the answer, honestly. We have 1/3 times the integral from 1 to 4, and our velocity function is 270 times the square root of t. Now, this one is not too terrible to do by hand, but at this stage in the game, on this assignment, I'm kind of like, let's just use the calculator for it. So let's do that. Again, it's good to review those steps anyway to know where the buttons on your calculator are. We're going to put 1/3 in front times. We're going to grab alpha f2 and grab our fn int. We're going to do 1 to 4, and then we're going to carefully program in 270 times the square root of, oops, see? Very carefully, I said. Delete that. Times the, can I push the second key here? Square root of x. There we go. dx. Oops. Perfect. And that should give us, 420. Very cool. The unit here, this is an average velocity. So the average velocity is miles per hour, I think. Yeah, mph. That's the average velocity flown. So somewhere in that range from 1 to 4, they were going exactly 420 miles per hour. That would be a question you could answer to, is when that happens, but we'll deal with that. And we got 461. I have about 5 minutes until third hour starts, so let's see if we can try. Given these functions here, we are going to evaluate the following limits. So let's talk about the limit as x approaches 1 of f prime of x. This would be the limit as x approaches 1. These are no calculator problems here. F prime of x will be the natural log of 3 times 3x. So since that's a perfectly continuous function with no problems, you can just plug in 1 for x. Let's do that. We're going to plug in a 1 for x, and that would give us 3 times the natural log of 3. That's that. The first rule of limit problems is that if there is no discontinuity, then you don't need to worry about anything. For question B, the limit as x approaches pi over 4 of g double prime of x. might be a good idea to map out what our derivatives over here are. We have 1/2 sine of x. The derivative of that is 1/2 cosine of x. And the derivative of that is negative 1/2 sine of x. So we are looking for, since sine is a perfectly continuous function with no breaks, we are literally just going to plug in pi over 4. So we're literally looking for negative 1/2 times the sine of pi over 4. And sine of pi over 4 is square root of 2 over 2. So this is negative square root of 2 over 4, since we're multiplying it by 1/2. Question C, limit as x approaches pi of f of g of x. So, might be a good idea to map out what f of g of x is. It would be 3 raised to the 1/2 sine of x power minus 2. And again, that is a perfectly condensed formula with no breaks. It'll be perfectly continuous. So all we got to do is plug in pi. Plugging in pi for that right there. Again, no calculator allowed on this. So sine of pi is equal to 0. If we rotate around the unit circle at pi, we're at a y value of 0. So this is going to be 3 to the 0 power minus 2. That is 1 minus 2, which is negative 1. D is asking for f of g prime of x. Okay, so f of g prime of x would be 3 to the 1/2 cosine of x power minus 2. And this time we're going to plug in pi over 2 for x into that problem. Again, this is going to do the exact same thing because the cosine of pi over 2 is 0. The x value at the top of the unit circle is 0. So this is going to be the same answer. It's 3 to the 0 power minus 2, which is negative 1. For questions E, E is a formal definition of a derivative formula. Its limit as h approaches 0 of f of x plus h minus f of x over h. This is literally asking us what f prime of x is. This is the formal definition for the derivative. And the derivative of f prime of x, we kind of found it up in the previous problem A. The derivative of f prime of x is the natural log of 3 times 3 to the x power. Because the derivative of 3 to the x, you have the natural log of your base times your base to the x power. That's the derivative of a base to the x power. Keep in mind that this derivative is not on the AP Calculus test. But you may have a professor that will show it to you and expect you to know it. So, if my job is to prepare you for college math, there you go. Question F is the same kind of question, just a little differently here. This is the other formal definition for a derivative. This is asking us what is g prime specifically of pi over 4. So this is the formal definition for the derivative that looks like this. Limit as x approaches c of f of x minus f of c over x minus c. You can see that the actual value is a part of it. Pi over 4 is where we want that to happen. And, of course, square root of 2 over 4 is g of pi over 4. That would be that. So we're looking for g prime of pi over 4 is what we're looking for. G prime of x, we already kind of know that because we mapped it out up above. It is 1/2 cosine of x. So g prime of pi over 4 is 1/2 times the cosine of pi over 4. And the cosine of pi over 4 is the square root of 2 over 2. So this is the square root of 2 over 2. Oh, over 4, because it's got to get multiplied by 1/2. So positive square root of 2 over 4. And that is all she wrote about 7.1.6. We got out of here in less than 30 minutes, and I only stared at the problem blankly for 5 minutes during that. So hopefully this video was of help to you. You guys are awesome. You have Tuesday off, which is cool. I'm going to give you a take-home test, though, for related rates. So secret there. All right, third hour's coming in. I'll see you guys in the next video.